All right, my name is Mike McCully. Welcome. Today we're going to be talking about construction-initiated landslides. That is, slides that have occurred from construction of resource roads and logging roads on the coast of British Columbia. We know that these slides are happening. We know that they're not acceptable. We know that they're costly, both in terms of monetary value, environmental considerations, and human life and injury. We have looked at these slides over time, and we know that there's been several of them over the last short while on the coast of British Columbia. As a result, industry came together with government and sat down at the table and asked, what can we do about some of these things, and how can we address that? As a result, the Construction Initiated Slide Working Group was struck. We are a subgroup of the Coast Harvest Advisory Group. Coast Harvest Advisory Group consists of coastal licensees, contractors, and is supported by government, but it's an industry-led group. Its initiative is to try to increase safety within the forest sector and reduce some of these injuries and incidents. A little bit about myself. I'm a registered forest technologist with the Association of BC Forest Professionals, and I live in Port McNeill, where I work. I've been there for over 20 years now, working in the forest sector. Most of my experience is in engineering. I've been responsible for layout and design of roads. I've supervised construction. I've done post-harvest inspection, and unfortunately, I've investigated several of these landslide events over my time. I have not yet had to go deal with a fatality, and I really would not like to. So I'd like to thank you all for paying attention to this presentation. It's very important. I'd like to thank you for your diligence, and I'd like to thank you for helping us work through some of these issues to make a better, safe place for you and I and everybody else who deals in these issues. During this presentation, we'll give you a brief outline. We're going to talk about the formation of this group. We're going to talk about some of our mandate, what we're trying to achieve. We're then going to get into the details of the construction-initiated slides. We're going to talk about some of the contributing factors. We're going to look at some personal safety related to landslides. We will then review some of the factors that contribute to them and some of the ways we can mitigate, such as the plan, soil conditions, drainage control, construction techniques, what to do when you change the plan or why a plan should be changed and when, some of the costs associated with these landslides, both environmental, human, and monetary, and then we're going to sum up with a conclusion. There will be several presenters during the course of this information session, and they will introduce themselves as they come on board. So again, the Construction Initiated Slide Working Group was struck through conversations around landslides. The forest industry knew that something had to change. Things needed to get better. So this group was tasked with coming up with some recommendations and factors to eliminate these types of landslides. The committee consists of a collection of professionals such as myself, geoscientists and foresters. There's road building contractors that sit on our committee, and we're supported also by provincial agencies. And again, our focus is to improve coastal road construction to the point where we are minimizing and reducing and in fact eliminating these types of landslides. We have short, medium, and long-term strategies. We're trying to look at some of the quick wins, also trying to look at some of the deeper, more challenging issues and come up with something in the big picture as well. So our working group is focusing on data collection. That means how many slides have we had, when and where were they, what caused them, what are some of the contributing factors. We're going to focus on raising awareness within the industry around this significant issue. We're going to talk about some training methods and resources for crews and professionals, such as this presentation you're looking at. We're going to hopefully identify some new ways to build road and work through some of these sensitive areas to make these work sites a little bit safer for everybody. And we're going to explore some options for monitoring and enforcement of the construction standards. And we are also very much looking for road crew feedback. It's very important to what we do. We recognize that road constructors and operators of equipment are very highly skilled professionals, and that can't be overlooked. So again, for some background, we know through our data analysis that between 2012 and 2015, we had 36 construction-related slides. These are the ones that we know of. These are the ones that have been reported and that we're aware of. Many of these involved excavators sliding down the hill, such as the one you can see in the picture on the left. Fortunately, we have had no fatalities during that window, but we have had significant injury. We know that some of these operators have in fact left the industry and never gotten back in the seat of an excavator. We also know that the cost of slides, the monetary cost, can be very significant. We've seen some of these costs range from $200,000 to $500,000. So although there's no physical injury, the cost of these is certainly enough to bankrupt a contractor in some cases, and that trickles right on down the line to all the employees. So not a desirable place to be. If you look at the slide on the right, clearly we've got some significant environmental damage as well, and this has to be considered. Forest industry on the coast is very proud of its ability to work under environmental management systems and leave the lightest footprint we can. So when we're having these types of landslides, we're certainly not feeding into that mantra. So we're going to start off by going through some examples of some construction-initiated slides on the coast of British Columbia. We're going to do this just to give you a sample of what's happening out there. Some of you will be aware of these, others won't, but we're going to show you what we've seen and another reason why we're sitting at the table trying to come up with some ideas and solutions. This picture demonstrates a set of landslides that occurred in a place called Huascan Lake. Huascan Lake is located on the central coast of British Columbia, mainland portion. Both of these slides occurred within one potential cut block setting, and you can see the road heading in the picture as well. You can see how close these two slides were to each other. I would like you to take note of the excavator number 1 at the bottom of slide 1, excavator number 2 at the top of slide 2, and I would also like you to pay attention to the two fallers noted in red at the bottom of slide, at the bottom right corner of the slide. These slides occurred, the first one occurred in April, the second one occurred in July. They're very long slides, as you can see, both several hundred meters long, and conditions for both of these slides was what we'd consider relatively dry for that time of year. So let's get into a bit of the detail. This is a photo of the top of landslide 1, or the head of the landslide. This occurred in April. So this slide occurred on moderate slopes, 30 to 45%. It was balanced cut and fill, and the road heading was currently transitioning out of a bedrock-dominated cut. So they had just started excavating into a thin pocket of wet, organic-rich soil, which is very common to that central coast mainland portion. And it was over top of some compacted gray, sandy clays. Above the landslide, the slope showed some wet site indicators such as skunk caps, which you can see in the picture. And there was also some Indian hellebore noted in this site. So those were potential indicators of something wet going on under the ground here. Now this is the bottom of the slide. So this excavator slid several hundred meters on moderate slopes down to the old road. It was then hit again by more landslide debris and slid another 100 meters before it stopped on a bench. You can see from the photo that this excavator ended up half buried in mud and surrounded by trees. Obviously not a fun situation for the operator, and we know that there was some significant psychological impacts that happened to him, and it was very challenging for him to get back in the seat and continue his career. To remove this excavator, the tote road had to be built, so there was extra cost added to this project. WorkSafe investigated this site. Geotechnical reports were obtained. Further investigations were done, and there was quite a bit of follow-up work to do. We know for a fact that this road heading was shut down for a significant period of time. Eventually, the road was moved into the bedrock a little further uphill. Several full descriptions were added, and it was felt that it was safe to proceed even through these wet areas with a little more cautious approach. But the key message there is the show was shut down, and there was a significant time and cost added to the project. Once road construction commenced, landslide 2 happened, and that was in July of the same year. Again, similar slopes, 50 to 60%. They're moving through a wet draw. You can see similar types of soil in this picture. The prescription here was for full bench end haul. Clearly, full bench end haul was not occurring. Rather, the operator and the hoe were working on punching on top of wet organics. This is over top of compact gray sandy soils, and that's just a condition that's ripe for disaster, which is exactly what occurred. Similar to the first landslide, the operator heard and saw some water flowing around him. The ground gave way about 20 meters below the road, and the excavator slid about 20 meters downhill before his bucket grabbed hold. Then the landslide continues as a mass of mud and debris, and it went about another 150 meters until it crossed the lower road, and in the end terminated about 250 meters down on some lower benches. So a very long, significant slide. Certainly, for me, I was very encouraged to see the excavator still at the top of the hill. Who knows what the result might have been if that machine had slid all the way to the bottom. Eventually, this machine was winched back up the slope, but not after WorkSafe came out to investigate, as well as continued investigations from the licensee. The geoscientists had to come back in and take a look, and ultimately it was decided that this road heading should be terminated due to very high risk, and this harvesting opportunity was ultimately lost. The next example is of a slide that occurred on Yeo Island. Yeo Island is also located on the Central Coast. This particular operator was just completing an end haul transition zone. He was in some moderate slopes, again 50 to 60%, when he encountered a pocket of deep, wet organics, similar to what we saw in the previous examples, and some subsurface water. I visited this site, and you could actually see water piping out of the hillside just above this landslide. These obviously were not identified on the original plan. It was dry conditions. You wouldn't have seen them, and you wouldn't have noted them. So very tricky to catch all that in the plan, but in the end, the operator saw it. The operator didn't stop and ask. The operator didn't stop and seek any clarity or advice on the plan or the change conditions that he was noting. He continued to move ahead and ended up with his excavator on top of wet organics over smooth bedrock. And very quickly, his excavator decided to migrate to the bottom of this hill slope in a landslide. This picture gives you a little bit of an idea of how potentially disastrous this could have been. Why the excavator stopped and flopped over on its side and stayed put there, we're still not sure, but we're very fortunate, and the operator was also very fortunate. This operator left this site that day and never, to my knowledge, got back in a machine or built road again. On top of that, this site was shut down for 6 complete days. During those 6 days, geoscientists, WorkSafe inspectors, company reps, and others inundated this site while they tried to come up with a second plan. Ultimately, we had to build a tote road down to this machine and remove it. So think of all the costs involved with those things. In fact, here are some of those costs. Again, while this operator wasn't physically injured, very significant incident for him. This picture shows, again, how little that excavator looks in that big slide. But in terms of costs, there was cost to repair the excavator, cost in lost production, cost in transportation in and out of this site to come up with remediation plans. There was professional administrative costs, and we also had to incur, the contractor incurred a $26,000 cost to build a tote road to recover his high-valued excavator, and the lost harvest opportunity was approximately $400,000 on this site. So these numbers were reaffirmed by the contractor, and the total direct cost of this landslide was $549,500, and that's just the monetary cost. It does not include the human impact. Think of how that bill could impact your contracting company if you had to receive that. The next example is a landslide that occurred, but it has a little more favorable story and a little better result. This landslide occurred in Holberg, which is located on North Vancouver Island. It occurred in a very dry period, in fact, a period of several years of drought. The landslide occurred near the height of land and was in a conventional construction section, again, a cut and fill type construction section just coming out of an end haul piece. Slopes were around 50%, but here's where things are different from the previous examples. In this particular case, as the operator was moving forward, he noticed a very deep, wet, organic pocket in the transition zone out of the end haul. He had just come past the bedrock knob, and then things changed. He noted what he called blue clay, which on the local crew meant trouble. If you saw blue clay, you knew you were in a tricky situation. What this operator did really well was he stopped and asked for a reassessment of the plan. It's never easy to stop. We know that it costs money, We know that anytime you have to shut down your productivity, it's not a good thing from a monetary point of view. But in this case, the operator stopped and asked for a reassessment of the plan, and it turned out to be a very good thing. With the operator's professional advice, and upon a little look at the layout, we decided to move the center line into the bank. We approved additional end haul, which increased the cost of this road, but that was not a hard decision to make. We knew that safety was the top priority, and we certainly didn't want anybody ending up at the bottom of this hill like you'd seen in the previous slides. So even though we moved the road in slope and we took some time and reassessed this plan, we still had a slide. Message there is, these things can happen, even if you put your best foot forward, but the critical piece is stopping and making sure you're doing the right assessment and you're asking for help. Again, no equipment was impacted, no personnel ended up at the bottom of this hill, likely due to the proactive approach taken by the operator. If the additional end haul had not been approved and the center line had not been moved in slope, I think it's fair to say that it's extremely likely that excavator would be down at the bottom of this hill, and we're not sure what those consequences could have been in terms of life and injury. There's also environmental damage that goes along with these slides. This slide was about 1/4 of a hectare in size, so about 1/2 acre, and that's relatively minimal compared to what could have happened if this operator had not stopped and taken the time to ask some real hard questions and provide his professional advice on the ground types that he was seeing. Cleaning up the slide was also a lot easier simply because the slide was smaller than it likely would have been. And again, key message here, nobody was injured, and that's really what we're focusing on. So we'll talk a little bit in this presentation about some of the contributing factors to slides. We know they occur on Vancouver Island, through the South Coast, Haida Gwaii, and Central Coast areas in a regularity that frankly just isn't acceptable. So some of these factors that affect the risks of the slides, they range from environmental factors such as water, weather, soil types, and bedrock to other factors such as planning, production, how are you doing business out there, and obviously operator competence comes into play. If you have the wrong operator in a tricky situation, you can certainly be adding to the risk of creating a landslide. And change conditions. What do we do when we have a change in conditions? What do we do when we see something that looks different than the plan? These are all factors that are very important to be considered as we move through these road headings. I'm going to wrap up my section of this presentation talking about personal safety. I'm going to give you a few slides that discuss some of these factors. Again, the reason why we're here talking is about personal safety. We want to ensure everybody's making it home at the end of the day just like you do. So it's paramount, and that includes the planning and construction phases. This isn't just about how the operators are doing business. This has to do with the plan as well. Like any other work site, if a potential danger or hazard exists, if you're seeing things that you think might cause a landslide, it's very important that you stop work, move to a safe area, talk to your supervisor. Very important that you do these things. The results of those could be a change of operator. They might result in a change of plan. That might include a reassignment of personnel. But the alternative of a fatality or significant injury just isn't acceptable. Personal safety includes always being aware of your surrounding and associated site conditions. This is a rock slide that occurred down on a main line. Imagine what that would have looked like if there was humans involved with that. So when you are noting these hazards, it's important that you communicate them. If you're aware of something that might result in this, you have to report that. And it's important that you pass this information on to other members of the crew, the supervisor. If you're changing shifts and you know of an unsafe condition, it's paramount that you talk to everybody about these things. Safety issues cannot be over-communicated. It's very important to pass on what you know. As a professional operator, you have very good knowledge. You need to share that with everyone. When you're working down the road, what do you see above you? Here's an example of a cut slope failure that happened above the road. If you're seeing signs of this, and if you look on the right-hand side of this photo, you can see very fractured bedrock. In the center of the photo where the failure occurs, you're seeing those deep organics again. So when you're seeing these types of things that look unstable and they just don't look right to you, it's time to possibly think about stopping having a better look and communicating that up and down the line. So the most important message with personal safety is don't risk it. Play it safe. Be conservative here. This is your life we're talking about. Thank you.
Hi, my name is Del Ferguson. I'm a geoscientist on the coast, and I do a lot of terrain stuff, dirt and rock stuff, as part of the plan. And so that's what we're talking about now is the plan. It takes just about everybody out in the bush to do the right job here, and those in the office too. So we start off by planning our roads, and then we go into the field and we're doing engineering, dirt surveys. It's called geotechnical here. It's basically dirt and rock, drainage. We're looking at everything we can to make sure that we can build those roads on the slopes that we do, and it's not really impacting the environment or impacting the safety of those out there in the job. The final road and plan design gets basically is the combination of a whole bunch of foresters and other professionals working together and getting what's needed on that construction pre-works for you guys. You're next in line there. Your supervisor gets the pre-works. He passes it on to you in a tailgate meeting or something similar. And then we go straight into the road construction phases where you guys are strong, and as you build your roads, of course, that gets reviewed, and we make sure it's all set up nicely, and we're not running into too many problems. From there on, we can have some nasty-looking plans, something like this. You got to be able to read this stuff, and mostly it's telling you how other people that have investigated the area, the slopes you're on, the ground you're in, figure that road needs to be constructed. If you're going to be stepping outside this plan, then you need to talk to your supervisor, who needs to talk to the other part of the team members who have actually come up with this plan to say it's the safest and the best way to build this road and harvest this area. So have a clear understanding of that plan, even though it may look pretty gruesome from the start out. Just make sure you know what you're looking at. If you got questions, talk to your supervisor, and then if he's got questions, he can talk to the what's called the coordinating registered professional, who will deal with what exactly needs to be done on site there. Plans can look pretty hairy. Here we have cross sections on the left, profiles on the right. So the profiles on the right are sort of how this road is grading up the slope and the dips and the gullies and everything else. And it also should tell you your special road construction sections, your end haul, where you're supposed to end haul, where you're not supposed to put stuff over the side of the road, side casting isn't allowed, that kind of thing. And your cross sections will tell you the same thing, but in a view that's basically looking down the road when you're coming up to it, and it's telling you what that designer thinks that road should look like. Now, you're probably, a lot of you are going to be laughing because you're saying, oh, that's not what it looks like, really. But yeah, we do have, sometimes there is problems, but if this doesn't look exactly like what you're seeing out at the cab of the excavator, maybe you should stop and talk to your supervisor and say, well, who did this? I mean, there's no way I should be, cutting this much rock or this kind of stuff. So we need to know that. We need to have that feedback mechanism on those plans and profiles. Quite often, if it changes substantially, there definitely could be an issue with regards to where you're hitting those targets. Quite often there's control points, so we can have the road up or down the slope from that center line. So if you're going to be substantially off that center line, your supervisor needs to know about it and where that target point is and make sure you can get back to it. The more into the slope you are, the better, the safer you are. Of course, I think we all know that. Quite often, if you see that center line hanging out over the slope, maybe you should stop and say, hey, I'm going to bring this in. If it's significant, stop work and consult your supervisor first before doing that. All right, this is where we'd all like to be. We'd all like to have these little gadgets in our cab. And certainly, it's nice to have. We're getting there. A lot of people have it. It's also the big thing is making sure that the maps that we give you, you can either read in your cab or have in your cab, or you have a system like this where it's telling you where those steep slopes are, where your rock hazards are. All plan maps should have on what your hazards are along that road. And make sure if you see a hazard out there and it's not on the map, then you better stop work and get it put on the map. So the things that I look for when I'm out there, much before you guys are, I look for signs of instability on those slopes. Here we've got some sort of pistol-butted trees, lots of deer fern. You can see the soil parting on the hill slope here. So you see it's like little mini benches, and the soil's parting, basically breaking away from the main mass. These slopes are actually holding moisture in certain areas and parting it and letting it go in others. So let's be aware of that. I don't always catch these out in the field. Like sometimes they're hidden by, especially on old roads and stuff, they're hidden by alders or something like that, and I don't get to see them. But when you're in your excavator and you're uncovering that stuff, you might see something we don't. And in that case, stop and ask for assistance on this, whether you should be proceeding or not. Here we see some pistol-butted trees, lots of deer fern, very open slope. Those trees are pretty wonky looking. You probably don't want to be cutting the toe of that kind of slope. And here's a good shot. This is a prime location on this one where we've got a lot of loon poop over smooth bedrock. What do we usually want to do? Pull in some puncheon, which is okay if you're on fairly gentle slopes and you're well in the inside. But if you're on steep slopes, puncheon is not recommended. Bring that rock in there, build that road subgrade up. Make sure you're sitting back into that hillside, and don't be hanging over the edge there. Organics is one of the worst enemies out there. So continuing with soils and terrain, which show some slope movement or what we call soil creep. These areas should be avoided. So if you're coming along in an excavator or on a drill or in a dozer or whatever, and you're seeing this kind of activity where we've got a big new scarp that's come in and it's not on your map or no indication of hazard or anything, stop work, go back to a safe place and let's get somebody else in to have a look at this, because it may have been a time since your road got approved, and maybe this thing has happened over the winter or maybe over the last 5 years. We're not sure when that geo was in there looking at that. So make sure you stop. Again, these are sort of what we call jack strawing of trees. So this is looking down one of those slides. I think it's the one on Huascan where we actually full bench end hauled through the top of this, and we're looking down through that. And you might think, well, that looks like normal forest, but it's really not. These trees are crisscrossing and going all over the place. We call it jack strawing. Some people call it drunken forest. That's the kind of stuff you don't want to be hanging out on for too long. You want to be sitting on a good solid platform when you're constructing that road, and probably not putting anything over the edge either. It should be a full edge section. Here we got some really thick clay soils acting as water barriers. Hard pan soils. This was a area of slide initiation on that second landslide in Huascan. Got organics over top, so they're sort of soaking up the water. This is not letting the water through, so we've definitely got some water barriers happening, and things can happen on steeper slopes there for sure, and even on moderate slopes. So. Rock, although it's one of our best friends out there, we like to have a lot of rock around us when we're building road. It can be pretty deadly as well. Here you see this is a nice failure plane right along here, and there's that rock hanging out over top. So, if we were to go ahead with this road, we got to undermine all this rock. It's coming way down from up here, probably about a 50-meter length, and then back down on the road. So we want to excavate that rock. It's going to be pretty slow excavating if we go through there, and a lot of volume. And then you got to evaluate, is it worth it? anyway, big thing here is to stop and talk to your supervisor, and if you got to get somebody else in to relook at this, do so. All right, here's another example of some fractured bedrock. Here you can see basically a little tiny hemlock holding up some big shards of rock here coming off this bluff. So these should always be on your plans. We should have these outlined and say, you know, there's definitely a potential for rockfall here. So if you don't see that, you're seeing this in the field, and you don't see that on your map, hey, maybe you better think twice again, stop work, call somebody in, and get it reevaluated before pushing ahead. This is one lots for organics. This was a slide that actually started on probably 40 to 50% slopes above, a yarder sort of pulling down, and all of a sudden it hit a big patch of skunk cabbage and went slowly down the slope, and then all of a sudden hit a 10-meter high bedrock bluff and picked up steam and basically flooded right up 6 meters to the grapple yarder operator's feet. So that also pushed the grapple yarder back, I think it was a meter back off the road. So no major damage done, no injury, but scarier than heck. And here we have some other material sort of hanging out. Sometimes we're building roads through this organic material, and it can be soupy enough to just plop out and go places. So just be aware when you got a lot of this black stuff hanging around. These are some of the plants. Skunk cabbage up on the top right here, false hellebore, fields of those. They're often sites of real organic sites. Same with a lot of Devil's Club. Again, we see a lot of these in old slide tracks and everything, a lot of indications of water. Salmonberry, you see a salmonberry on this slope that failed, gave us an extra high cut here we weren't expecting. Drainage control, really important. As you guys know, I can't stress that enough. It's really critical here. Basically the waters won't run down the road grade here and taking out what I believe is the inside ditch on this side. On the right-hand picture here, the ditch block is way too high, so if I dig it, if there was water coming down that ditch line, it's going to pop over that ditch block and cross the road and take out the fill slope probably. It's not going to, so keep that ditch block below that, below your road surface there so it can flow down the next culvert if it really wants to take off. Drainage control again, here's some stuff. Maybe we need a bit more armoring around this sort of catch basin here for the culvert. It's washing right out. We've got a lot of fines coming down and going to plug this culvert pretty soon. It's going to take off on us. As you can tell, this road was a bit of a hassle here because we've got lots of highly erosive sandy sediments coming out of these banks. So even building the road was a real challenge. Here we've got, again, sticking with drainage control. This is one where the drainage wasn't controlled, wood in the subgrade. Eventually these old roads give out when we're on steep slopes and you got wood in the subgrade. And away you go, there goes. We can't even get through there. And now we've got what looks like steep bedrock on the left-hand side, and chances are it's going to be too much to take out to reopen this road.